Okay guys, so last week on Friday we were looking at systems of inequalities, which were more than one inequality. A system of equations looks exactly the same. There's more than one equation in there. So we have to deal with two or more equations at the same time. We are not going to be solving these by graphing though. We're going to be solving using either the substitution method or the elimination method. So let's do substitution method first. There's 5 steps. Step 1, you want to solve one of the equations for one of the variables. Okay, so basically we want to get one variable by itself. Okay, so we want to get one variable by itself. Okay. So we get one of the variables by itself, either x equals something or y equals something. A lot of times you will use substitution when you already have one by itself. Okay. Step 2, you're going to take the equation from step 1 and plug it into the other. So we are going to substitute equation from one into the other step. So if we have x equals something, we're going to plug that something in for x, which will only give us one variable. So we're going to solve for the remaining variable. Okay, that's going to give us an answer to one variable. Alright, we need an answer to the second one. So we're going to substitute your answer from part 3 back into 1 and solve for your other variable. So we do substitution twice actually. And then your answer should be a coordinate pair, x comma y. Okay? So let's do this in an example. Example 1. My system is x plus 4y equals 1 and 2x minus 3y equals negative 9. So I have two equations in this system. Okay, so substitution, if you look at step 1, it says first we want to solve for one of the variables. Look at each of these equations. Or does any variable look easy to solve for?
The first one.
Yeah, look at this first equation and look at x. X is already by itself, so we just have to get it all by itself. So what would I do here?
Enter it into x.
Well, first we need to subtract 4y from both sides because it's not x equals yet. So this equation is going to become x equals negative 4y plus 1, or 1 minus 4y, same thing. So now I have this guy. So here I have x equals negative 4y plus 1. So what I'm going to do is I'm going to take this negative 4y plus 1 and stick it in parentheses because we want to keep it all together. And we're going to cut and paste it into x into the second equation. So I have x equals this guy. So what I'm going to do is take that guy and plug it in for x here. So that's going to give me 2 times x, but x is equal to negative 4y plus 1. Then we continue on. Minus 3y equals negative 9. Now we want to solve for the only variable that's left, which is y. So the whole point of doing that was so now we only have one variable in there, and that's y. So I'm going to use distributive property first. So that's going to give me negative 8y plus 2 minus 3y equals negative 9. I can do some combining like terms. I have negative 8y and negative 3y. So that's going to give me negative 11y plus 2 equals negative 9. And now solving for y should be pretty easy. We subtract 2 from both sides. That gives me negative 11y equals negative 11. Divide both sides by negative 11. And I get y equals positive 1. Okay, that's part of my answer, so I'm going to put a bubble around it, but that's not my full answer. Okay, that's only part of it. Because step 5 said my answer should be a coordinate pair x comma y. I only have the y's here. So what do you think I'm going to have to do to find out what x is?
Plug y into.
Plug y into that thing right there. So we have x equals negative 4y, and this time we know that y is positive 1 plus 1. So that gives me x equals negative 4 plus 1. So x equals negative 3. That's the second half. How would I write that as a coordinate? Which one comes first? The x, so negative 3, comma 1. This is what your answer should look like. Please do not give me x equals, y equals. Write it as a coordinate. X comes first, then y. Y equals 3x minus 8, and y equals 4 minus x. Alright guys, are we solved for a variable yet?
Yes.
I see some shaking their heads and some saying yes. Do I have x equals stuff or y equals stuff?
Yeah.
I do. I actually have it in two places, right? Here I have y equals and y equals. So what we can do here is we can decide whichever one we want to plug in. I always go for the top. So put parentheses around the top. And like I said before, we're going to cut and paste. So this guy is the same as y, so we're going to plug it in for there. So we cut from the first one and paste it into the second equation. So what does that give me? 3x minus 8, that's the same as y. It says y equals that thing. Equals 4 minus x. Okay, so I need to solve for x here. So I need to get all my x's on one side and all my numbers on the other. And I notice here that I have a minus x. So what I'm going to do first is add x to both sides. Those will cancel. And I'm going to get 4x minus 8 equals 4. Add 8. 4x equals 12. Divide by 4. So x equals 3. Bubble that, we're not done. So I have x equals 3, but I still need the y. So how am I going to find the y? Plug it in. It doesn't matter which one we plug it into. Who wants to plug it into the first? Who wants to plug it into the second? Second's a little bit smaller. So we have y equals 4 minus x, which is 3. So y equals 1. So this is not my answer, though. I need to write my answer as an ordered pair. X comes first. So 3, comma 1. That's what your answer should be. Okay, so that was substitution. My favorite method, the one that I prefer, is elimination method. So what we have to have for elimination is we want to put both equations in standard form. That means x and y are on the same side. So x and y on the same side. Okay. The coefficients on one variable should only differ in sign. So you want to get coefficients for, say, the x's to be the same, except for the sign. We're going to add the equations to eliminate one of those variables. And then we're going to get an answer for one variable. So then we're going to substitute that answer into one of the original equations to get the second. And then we want our answer to be a coordinate pair. Alright guys, example, this one says 4, but it's actually 3. Okay. So example 3. We have 3x minus 2y equals 4. and 4x plus 2y equals 10. Okay? Okay, so step 1 says to put both equations in standard form, which means x and y are on the same side. Are these already in standard form? Yes, they are. Okay? Step 2 is the most important part. We want the coefficients of one variable to only differ in sign. So looking at these guys, look at the x's. We have 3x and 4x. But then look at the y's. I have minus 2y and plus 2y. This is exactly what we want. We want the coefficient to be the same except for the signs. Okay, because look at what happens. When I add the equation straight down, what's 3x plus 4x going to give me? 7x. What is negative 2y plus 2y going to give me? 0. So we eliminated the y's, which is what we wanted. Equals, what's 4 plus 10? 14. Okay, do you guys see how nice this is? We just got rid of the y's, so now I have 7x equals 14. So I'm going to divide both sides by 7. And I get x equals 2. Okay, that's not your whole answer. That's only part 1. I still need y. So if I have x equals 2, what do you think I need to do to solve for y? Plug it in. Doesn't matter which one I plug x into.
No.
It doesn't. You can plug x into whichever of the equations you want. So I'm going to do, why don't we just do the first one? So we have 3x, x is 2, minus 2y equals 4. So that's going to be 6 minus 2y equals 4. Subtract 6 from both sides, and we get negative 2y equals negative 2. Divide both sides by negative 2, so y equals 1. You okay? Okay, do not give me x equals 2, y equals 1 as your answer. Your answer needs to be in an ordered pair, 2, comma, 1. So example 4, what happens when my equation is not set up perfectly like it was in the last
You
one?
have to make them
So,
equal, or it's incomplete.
yeah, so we have, it's okay. So we have 2x plus 5y equals 14. 4x plus 2y equals negative 4. Okay? Write it down really quick. Maybe take a look at it and see what you think we have to do. Are any of my variables the same except for the sign? I have 2x and 4x and 5y and 2y. Or will any of those eliminate right off the bat? No. So we need to pick which variable we want to eliminate. Any suggestions, x's or y's?
X's.
Why do you say the x's?
Because you can times 1 by negative 2 and make it equal.
Yeah, we only have to multiply one equation if we want to eliminate the x's. So notice how we have 4x. In order to eliminate, we want this guy to be negative 4x. So what would I need to multiply by to make 2x into a negative 4x? Negative 2. So you multiply the entire equation by negative 2. Everything. The x's, the y's, and the answer. Okay, so that's going to give me, I'm just going to write it below, negative 4x minus 10y equals negative 28. Okay, well it's a negative times positive 14, so it's going to be negative 28. Okay, we add the two equations together. 4x minus 4x eliminates. 2y minus 10y gives me negative 8y. And negative 4 minus 28 is going to give me negative 32. Divide both sides by negative 8. And I get y equals positive 4. And then we can take this y and we can plug it into any of the three equations that we have. So we could even plug it into this guy right here. And that's actually what I'm going to do. It does not matter which equation you plug it into, you will get the same answer every time. So I'm going to plug it in for 2x plus 5y, so 5 times 4 equals 14. So that gives me 2x plus 20 equals 14. Subtract both sides, 20 from both sides. So that's going to give me 2x equals negative 6. Divide both sides by 2. So x equals negative 3. This is not my answer. My answer is negative 3, 4. Okay? That's elimination.